Okay, it looks like we are live now, so I'm going to jump off. Thank you, everyone.
Thank you.
Hello, and welcome to the September 1st, 2021 Bitcoin Cash Network discussions. Today's topic is what's called native introspection, in addition to Bitcoin Cash's scripting language. Presenting today's topic is Jonathan Silverblood, co-owner of the native introspection CHIP, that's CHIP, also known as a Bitcoin Cash improvement proposal. Our other participants for today include Emergent Reasons, President and General Protocols, Jason Dreyzehner, co-author of the CHIP and author of Bitauth, Fernando Pelliccioni, developer for Bitcoin Cash Node and Knuth, and Calin Culianu, Bitcoin Cash Node and Electron Cash developer. So these discussions will be broken into four basic sections. First, we'll talk about the basic problem statement and or use cases relevant to the topic. Then we'll talk about the properties of a good solution and implementation and how this proposal specifically satisfies those requirements. Third, we'll talk about the costs of this proposal to the BCH ecosystem. And then finally, we'll cover who the relevant stakeholders are and any involvement from them so far. Each section will be started with a short presentation from Jonathan, after which we'll open up the floor to everyone else for both questions and comments. If you're watching the live stream, please do feel free to ask your own questions in the live chat, and we'll do our best to pass them along as best as we can. So Jonathan, whenever you're ready, please go ahead.
All right, so with native introspection, we can have complex smart contracts that are easier to understand and therefore easier to audit and verify. Also, due to the contract script being smaller than existing methods, we open up doors to implementing more featureful contracts. Having code that is easier to understand and verify also improves the security of contracts, as bugs tend to be more common in code that is poorly understood. While it might seem that the primary stakeholder of this change is the developers who get access to better tooling, the main benefit is likely to be for the users of the contracts created with it, as they will be cheaper and safer to use, and there will be more services available when the cost of development goes down as a result of cleaner and safer introspection. So for some real-life examples, like we have a high-security vault type contract that are used to intentionally slow down or regulate withdrawal. They would benefit from having significantly lowered cost of auditing, quite a heavy cost today. Actually, each contract has to be unique. Cross-chain bridges, having multiple other chains resulted in catastrophic security issues and would be easier to secure if we had native introspection. And we have a slew of other things like recurring payment, financial contracts, futures and options, fundraising and gambling products. There's a really a wide variety of things that can be done with introspection.
Great, thank you. So before I dive in, would anyone like to either ask any questions about that or maybe add on and provide any context where they think it's necessary? Very good, thanks. So could I ask you then maybe to, on a more sort of list one by one basis, describe again, just what were those use cases that you covered even just now, the couple of the list ones, and maybe if you're able to list a couple of the ones that you're saying are more generally covered.
Right. So I think it's easier to have Jason talk about the vaults because he has more information on those. But from my perspective, as one of the developers behind AnyHedge, we are using introspection today in the current workaround way, which is not ideal. It is causing us extra development costs. And if we could have native introspection, we would be more confident in the quality of our product. And it would also be easier for us to add additional features to it.
And on the, so to continue on the high security vault stuff, introspection would allow us to design kind of a new class of wallets that can validate the types of transactions that that are sent by the wallet. So, goodness. So you can have a wallet that will check if the withdrawal is sending to a pre-approved address. So you need to submit the address to the wallet 7 days in advance. You can have with full value withdrawal limits, so like weekly or daily limits that would prevent a compromise from sweeping the whole wallet. There are frequency limits that can be implemented where you can only have a few per day. So if there's some sort of physical security risk where someone creates a transaction and then they are they have a physical security risk if that key material stays in the same location or something like that. A lot of these features are present in the traditional financial system as for cash security features. Also time delays. So like where a vault takes 24 hours to unlock, or in many banks today, it takes 30 minutes for them to open the main vault. So a lot of cash security features like that exist in the traditional financial world and are incredibly important for a global peer-to-peer cash. But in the traditional fiat world, those features tend to require stable, centralized institutions, and they tend to only be available to people with a lot of money, who are very important to those institutions. So what I think is very cool, and probably the coolest thing with the native introspection opcodes, is that we can offer many of those really important financial cash security features on a software basis in a decentralized way to anyone in the world, regardless of the stability of the institutions around them.
That sounds great. Thanks very much. So that's the use case side of things. So then before we move on to what makes a solution good or not good, could you then just maybe reiterate? So some of these applications are already possible, at least in a sort of way. You can do covenants apparently, but not, full introspection. What are the types of security risks that come from having to use something that's hackier like we currently do?
So from a security risk perspective, it's mostly a matter of education. If you look at the people developing these applications, if they don't understand the actual signing process and the underlying mechanics of the Bitcoin Cash transaction system, then it might be possible for them to think that they are doing things in a correct way, but naively forget to do something like validating that the signature is the same for both the pre-image and the actual content you want to, the transaction you're looking at. And if you skip that validation, your code will run just fine, and it will use the data that you provided to. But if someone figures out that you're not validating properly, they can abuse that and bypass the security part.
Yeah, I'd like to emphasize that and bring it maybe kind of a pseudo use case. The security issue is big. Jonathan said people who are unfamiliar with it, but I can say that I'm not a super expert with smart contracts. I can write them, but I wouldn't call myself an expert. But even for someone of my level, I review another person's smart contract, and they have experience writing them, and I can point out a lot of times, oh, look here, you have some kind of vulnerability to submitting data in a certain way that will allow people to basically burn your money, that kind of thing, right? It's very easy to make mistakes when you force developers to work with very low level bits and pieces of the language that are really entirely unnecessary. There's no value in it. So the pseudo use case is kind of just making Bitcoin Cash more attractive and more friendly to developers and entrepreneurs who want to come in and use it, so that they don't have to have that kind of fear of messing things up.
Yeah, and the hack that Jonathan is mentioning is large enough, requires enough bytes that it can only be used usually once in a single transaction before you go over virtual machine limits. So in practice, it is also limiting a lot of use cases that would be very interesting. You can usually only do introspection on, for example, the first part of a transaction. If you try to do introspection on a couple bits of output, you lose a lot of flexibility just with the sheer number of bytes that it takes to do these kind of workarounds. So native introspection opcodes would make those things very, very efficient and very easy to develop and very easy to audit for security.
Thanks very much. So then let's dive right into what makes the solution as it's being proposed now one worth proposing. So what makes a solution or what makes an implementation of introspection good, and then how has it been implemented now or in its current form?
So there are a handful of properties that I think a good solution for contract introspection should have. It should not break existing applications. It should be efficient and scalable. It should be accessible to application developers. It should be safe to work with, and it should be ready for deployment on the short term. When we're talking about native inspection, it's a good idea to keep in mind that many of the things it enables can already be done, but that it requires a much more intimate understanding of Bitcoin Cash transaction structure and signing mechanics, and if implemented naively, can pose a security risk for the contract. The existing method for doing introspection is not a good solution, since it's inherently inefficient, difficult to access to application developers, and working with it comes with difficult to understand risks. There is, however, already a growing usage of introspection on-chain, and if we don't provide a good solution, it's possible that end users and business innovators will be the ones that takes on these risks from the current introspection method.
So from there, could maybe you describe a little bit about how? So okay, the way it's currently done is not great. In the more, and this might require delving a little bit into the technical side of things. Could you describe how introspection is being enabled in this proposal, and then in what ways it manages to fulfill those needs?
All right, so that's essentially just moving to the next section. So the native introspection chip introduces a set of new opcodes into the Bitcoin Cash scripting language that provides access to data about the current transaction. The data provided is from information that should already be present at the full node during validation, and is therefore low cost and efficient. The data provider has been selected to cover all the currently available features and some additional parts, and by having them as simple opcodes, they should be easy for application developers to get started with, and should be free from unexpected and difficult to understand side effects.
And John, if you don't mind, I'd like to add something.
Please go right ahead. Yeah, I'd like, actually, if you don't mind, I'm going to interrupt you just to say that once we kind of open things up, then please feel free, as people are comfortable, please jump right in. Go ahead, Emergent. Thanks.
Okay, thanks. Yeah, so the point of saying that sorry, I lost my train of thought. I'll come back in just a minute.
Well, before we get Emergent back, then would anyone like to elaborate or bring up questions or concerns about this implementation, and maybe if anyone has even just any supplementary information to provide to viewers who might be curious as to, you know, kind of what the meaning of this proposal specifically means.
I did have something.
Okay, sorry, go ahead, Emergent, then we'll get to you, Jason.
Jason, I'm going to make you lose your train of thought so that you can then forget, and then we'll go full circle. So what I was going to say is that having everything oh my God. Jason, go ahead. I don't know what's going on.
Jason, please go ahead.
I'm taking it. What might be useful to describe a little bit about how we are currently doing this stuff, because it is it's complicated, but it is understandable. There are two different ways that you can check signatures in Bitcoin Cash right now. You can check a signature that is part of the transaction, and that is the operation is opcheck sig, and then you can also check specifically a signature for a message. So the check sig checks a kind of a digest for the transaction it's currently in. and check data sig checks the signature for a message you give it. And so the workaround we're talking about is it's an interesting hack. You can provide the same message that the system provides to check that you're in the current transaction. You can provide provide that up front, provide 2 copies of it, and you check sig, and then check that the signature with that check sig covers the same message by checking the same signature with both check sig and check data sig. So there's a good article that maybe will be in the description if anybody's curious about that, or if you're curious, the native introspection specification itself describes that better. If you'd like to go and get more details there. But what that means is that in practice, in order to do what we're doing with these individual opcodes, where you have a single opcode that just pushes like the value, for example, so op UTXO value or something, in order to get that data in the virtual machine, right now, what script developers are doing are we are putting like a 300 or 400 byte message that is like the digest of the whole transaction, and we're like carefully constructing it and validating each piece of it and confirming that it's the current transaction, and then we check a signature against that message 2 different ways, and eventually we can confirm that like we're looking at the same message, and then we have to pick it apart and validate, just find the individual part that we want, find that certain output and prove that the value of that output is 5 or something like that. And it would be a whole lot easier if you could do op UTXO value 5 op equals. So the simplicity there is maybe cannot even be overstated. It is incredibly difficult to even follow a single introspection cycle in the current virtual machine. It requires significant investment and significant expertise to even kind of know what you're looking for. And even those of us who've been doing it for a while, like we will regularly find issues in each other's code that is just should not be things anybody needs to think about. You shouldn't need to worry about like if I submit if the value you submit is a byte longer than you expected, then it changes the way that you're no longer validating the value, you're validating the output or something like that. And so the attacker, instead of being able to submit a transaction that has $5 worth of Bitcoin Cash or something, they just have to submit a transaction that has an output that starts with a 3 or something like that, and suddenly the contract is infinitely spendable. And there's all sorts of weird issues like that are just they're totally nonsensical if you're not looking at the code, and they're not intuitive. A lot of very sharp edges to cut yourself on. Not to count how inefficient that is, because obviously it's not good for the network for us to submit 400 bytes of transaction data in order to check one thing that could be done with 2 bytes with opcodes.
Well, thank you for elaborating. It's I guess it's pretty clear that maybe the what makes a good solution is pretty obvious, and only really takes on its significance once we realize not only what a not particularly great solution would be, but the one that we're currently using is. So if there's nothing else that anyone would like to add on specifically to that section, let's talk a little bit about the cost of proposals. But if we'd like to keep yeah, go ahead.
I would like to. I swear I won't blank this time. I had my caffeine in the meantime. So one of the things is when we're talking about a lot of solutions that are ideas that people have, right? There's a lot of ideas that sound good on the surface, and then when you look at it, you're like, well, that'll actually break things. That'll break an exchange, or that'll break the way miners work, or that will break the way a bunch of libraries work, right? So I think one of the properties that makes a good change just generally is something, like Jonathan said, that doesn't break other things. And this chip is one that follows good engineering practice. It's very minimal. It does one thing. It does it well. It does it in a well-engineered way. And it just solves this one problem cleanly and in a way that doesn't break old programs. It doesn't break miners. It doesn't break the way exchanges do things. I think Jonathan maybe is going to talk later, I'm not sure, but I think he identified that there's only maybe 1 or 2 libraries that would be impacted by it. So a lot of work has been done to make sure that this isn't going to break anybody's software or applications. So I think that's a very important general principle for any upgrades to a network like Bitcoin Cash that's dealing with money. And this one definitely qualifies for that.
Excellent. Thank you. Yeah, I appreciate your elaborating. I think that is the kind of thing we want to hear when, you know, it's something that's going to affect the entire network, and a property of a good solution is certainly one that has had exactly what you've pointed out considered already. So if there's nothing else that to add specifically to that section, then maybe we can move on to the costs of the proposal to the BCH ecosystem. So Jonathan, if you could go ahead and take us through that.
Sure. So with the introduction of new opcodes as a hard fork upgrade, all full nodes and libraries that implement the scripting engine will need to be updated. For full nodes, failure to update would result in rejecting blocks that contains transactions used in data introspection. For libraries, the failure would be more soft, and they would be updated as they go. But that said, the only libraries we have in the ecosystem that actually implement the scripting engine have already stated support and is pushing for this change. To be clear, this change has no impact on wallets, exchanges, or other user-facing tools. From the perspective of opportunity cost, this is a low-cost proposal. It's relatively small as an isolated change with a good cost-benefit trade-off ratio. And from a consensus or social perspective, the native introspection CHIP has been reviewed by a large number of stakeholders in the ecosystem. And while there are some nuances and differences in opinion for some of the design decisions, every party that we reach out to agree that it's a good outcome.
That's great to hear. And of course, we'll get a little bit into the specific stakeholders in a minute. But first, again, I'd like to open up to anybody to either add on to that or ask any questions. So, you know, that was a succinct description of exactly who does and doesn't have to upgrade and who will be affected. But maybe if anyone else is willing to maybe give just a little bit bigger of an overview on who will be affected. And feel free, Jonathan, if you'd like to elaborate.
So I can mention that in the description I just gave, I didn't quantify the actual cost. Like I didn't say how much work it's be for a full node, for example, to do this. And I think we have people who are working on full nodes that can give a much better explanation of that cost. The same goes for the libraries. My understanding, though, is that the cost is actually very small compared to many other changes we could have made instead.
Can I say something? Just as an example, so I maintain Fulcrum and Electron Cache, and they talk to each other. Like Fulcrum and Electron Cache don't have a scripting engine. They don't really evaluate scripts. So that's an example of a system that won't be impacted. I won't even have to change the code there. It'll just work. You know, it just gets an input. It sees that the blockchain validated it. It trusts the blockchain. You know, this is like a low impact thing for a lot of the ecosystem. The only part that will be impacted are the people that are actually going to benefit from this. So that's the good thing, right? Like Fulcrum doesn't, and Electron Cache doesn't really validate. It doesn't care. You know, it doesn't have to put in any, you know, it's not going to you don't write contracts with Electron Cache, so you don't care. But parts of the ecosystem that do care, that will benefit, you know, they're going to get the benefit immediately, and they'll have to put in of course, a little bit of cost in terms of development, which I think they'll be very happy to do, because it sounds like this is like completely making their lives so much better. So just for, you know, just in that context, like, yeah, wallets won't have to, you know, exchanges won't have to care unless they're doing smart contract stuff. And nobody will even notice this except for the people that really care about it, and they'll really love it. That's basically my point.
That's great. Thanks. And maybe Fernando, if you're willing to give just a perspective on the scope of what is going to be required generally for the full nodes that will be implementing this change. Is this something that you're able to share anything about?
Yes, Calin and I started on the Bitcoin Cash node implementation. In fact, we have a work in progress or draft merge request presented. The most difficult thing for us, for Bitcoin Cash node, is to have the proper context information needed for the script evaluator or the script interpreter, because we don't have that information in the code that validate the scripts. So we have to fill that information. We have to provide that information to script evaluator, and don't break anything, and the contrary of improve is don't pessimize the performance. Don't degrade the performance, and then we have to implement the actual opcodes. But this is when we have this context information provided to a script evaluator, this will be simpler, I think. Then, well, I am working on Knuth node also, but after implementing this proposal on Bitcoin Cash node, I think it will be simpler to implement in Knuth because I will have the experience of the Bitcoin Cash node implementation. So this is my perspective, because I am contributing to Bitcoin Cash node, and I am the Knuth programmer.
Nice. Very good. Thanks. Oh, sorry, Jason. Yeah, go ahead.
Yeah, and I can say for libraries, libauth is one of the only client-side libraries that does anything with a virtual machine right now. And I was a co-author on the chip. So libauth will definitely be implementing it. It is non-trivial to implement in software like libauth, where our goal is to support even very fancy contract compiling and stuff. But it is non-trivial, but will be done there. And many of the other libraries that then use contracting tooling, at least in the JavaScript space, import from libauth. So actually just implementing into libauth will cover much of the JavaScript ecosystem. That covers cache script as well. Then and to note on the node implementations, kind of to summarize, it's non-trivial to implement, particularly in node implementations, where when we originally wrote some of these interpreter methods and kind of the general code structure, we did not envision that we would want this particular context in this particular location. But as far as the cost of running a node, nodes already have this information available at the time of transaction validation. It's just that when we wrote some of this code, we weren't expecting to use this context in this part. So there's a little bit of refactoring that needs to be done. But when the refactoring is done, the cost of running a node is equivalent, which is valuable. It's quite nice that we're not using any additional. There's no additional memory required. There's no additional data that needs to be retrieved from disk that isn't already being retrieved for the signature validation. So much of many of the requirements are equivalent. There's just a lot of refactoring to do.
Just to sort of underscore his point, like currently the way they're doing it, I guess, is they're checking signatures, basically, right? You're checking signatures, like in a weird way, with this huge byte blob. I mean, so if anything, this improvement, this upgrade will actually reduce the cost to run a node. You'll have smaller transactions and you'll have less signature checking. Signature checking is the most expensive part, or one of the more expensive parts of validating or just running a node in terms of CPU cost. So yeah, I mean, the information is there in memory already. It's just package it to the transaction script engine so it sees it. And it's just going to be a win in that regard as well. It's just execution costs, like node running cost is going to be lower. The transactions will be smaller and they'll use less CPU time. So it's like win-win-win. Just underscore that point.
I'd be happy to underscore it further. Introspection has a use case when it comes to recurring payments would make recurrent payments, particularly recurrent payments denominated in other currencies like fiat currencies, much more accessible. And if we get to the point where we reach really massive scale in terms of a payments ecosystem, then recurrent payment is going to be a significant part of that. A lot of people pay rent. A lot of people pay for Netflix subscription. A lot of people pay for things on a regular basis. And so if we don't implement native introspection and those use cases take off with the existing method, yes, then you're right. A lot of unnecessary signature checks is going to be happening on the nodes.
And John, I'd like to pile on here. This is one of the great things about this chip is it's kind of hard to find anything bad about it. But from the cost perspective, right, the original question is about costs to the ecosystem. And General Protocols is one of the companies that's actually has a product, right, has products in production on the Bitcoin Cash chain. And we will have to go back and review our contracts and make sure that nothing is going to break, right? But it's very much a situation where, you know, we're going to pay, I don't know, you know, we're going to pay $1 to do the review, and we're going to gain much more than that because of the amount of simplification that we're going to be able to do and the amount of features that we're going to be able to add in to make things better for people. Yeah, it's a very small investment for a very large return. It's one of the best things you can find in engineering.
Great, thanks. So then let's pivot into talking a little bit about the specific stakeholders. So it seems like there is general support, or at least according to members on this call, there's not too many issues about it that have ended up being contentious. But as far as the other examples of businesses that will have to do whatever amount of work is required of them to make the switch, or other examples of businesses that plan to make use of these use cases, are there any examples of either of those that are worth sharing in addition to what you've already shared?
I can say, so on the wallet side, I think a lot of the coolest use cases, the things that I was mentioning before, the security features that we can implement in wallets, that will certainly be non-trivial to implement. Much of it in the UX front, the user experience front, just building a wallet that is makes sense to users, helps them design their withdrawal limits, to cater the security of the wallet to their physical security and their location, their typical spending patterns, potential threats. A lot of that stuff is there's a huge field of development and research that will need to be done to make that stuff really good for average users. And typically, actually, in the fiat world, much of that is done with kind of a layer of consultants and financial advisors and people who directly consult with the kinds of people who have enough money to have these problems, have enough cash to have these problems. So there is a degree of work that'll have to be done to make those solutions available to kind of the common person, the common BCH holder. So that'll be non-trivial. There's a lot of development kind of tooling and work to be done. But I expect some of the existing wallets will take that up, and then I expect we'll see a crop of new wallets, new competitors to the space. It's been a while since a wallet in the cryptocurrency space in general competed on security. Actually, most wallets are competing on other little features. So there is definitely a possibility that we'll see kind of a new crop of wallets that come in to compete specifically on that kind of security.
Right.
Great. So of course there's, oh, yep, go ahead, Calin.
Sorry. Yeah, just to underscore your point further, like right now it's so difficult to write a smart contract in a wallet to do this type of security things you're talking about that it's just like nobody's going to do it. But with just adding these opcodes, they're really low hanging fruit. We could, like you said, we could see a new crop of wallets coming out and that are going to blow people away. Like, wow, like I could limit how much is spent from this wallet and all these other parameters I could specify. And developers that aren't necessarily blockchain super engineers will be able to use these opcodes. They'll make sense to them. There won't be all these hacks. And I can see this opening up just a whole class of applications, and just it's more developer friendly to have these opcodes basically. So it's going to make things just saner and motivate people to work on this. That's all. That's all I want to say. Just underscore your point.
John,
Thanks very
on
much.
the other part of your question about the existing solutions and existing things that are out there, the hacks that we're currently using will still work, right? So that's one of the nice things. It's not going to break anything. So for local.bitcoin.com using contracts to do escrows, or Zapit Wallet doing P2P exchanges, and others out there that I'm not aware of. But for the people that are already using some techniques, those still work. It's just that they will have the option to wipe out 90% of their code and leave it as just the meat of the code instead of all the junk that you have to do right now.
Right, sure. So it should, in its implementation, shouldn't disrupt too much. I wonder if we could talk just a little bit more about specific examples. So we've heard from, I think, just a couple of the nodes. You know, we've heard from the perspective of Bitcoin Cash node, and also Knuth from just from Fernando. So has there been outspoken support from all of the other node implementations about getting this implemented, or do they all have it in the works already, or is this something that is still being looked into as far as getting reactions from all the other node dev teams in the space?
So I can jump in and go through my prepared part about the stakeholders, because it kind of touches on this. So contract developers, either independent or as part of companies or in other organization, would be the most direct stakeholders of the native introspection proposal. They work directly with the new opcodes, and the vast majority of developers that we talk with are happy to see this change. Investors in the Bitcoin Cash ecosystem is expected to benefit and be happy with this change, as it comes with no cost to them and improves the value of the network. And end users that gets access to more services and services with less security risk is also expected to benefit and be happy about this change. To get to the more specific question you ask about other nodes, we reach out to all the teams that make a node for Bitcoin Cash. I think all of them have been positive in the response. Not all of them have started the work yet, but it's expected to get done.
That's great, thanks. I mean, I assume just the fact that they've all been contacted is, depending on your standards for communication, I think an excellent place to start. And I'm sure the Bitcoin Cash ecosystem looks forward to hearing publicly but confirmation from the various stakeholders that this is or isn't something that they are getting behind.
So I'll jump in and say I'd be happy to refer people to the actual chip. It lists all the stakeholders that we have reached out to, and for many of them, it lists the responses they have given us back. It's just overwhelmingly positive, but if you want to know who we've talked with and want to know which persons or organizations have already committed to doing this or have stated that they desire this, then the chip has a list of those.
Great, thanks. So we'll be sure to include that in the video description for anyone curious, first for the live stream, but we'll get it in the description for sure. So because this was or ideally will be a relatively smooth and non-contentious addition, this may end up just being a relatively short discussion where everyone's all excited to see things actually happening that will make things easier for developers on Bitcoin Cash and will make things more efficient. So I'd like maybe to then open things up a little bit more generally to comments from anyone who's currently on the call with us who wants to even maybe just comment about what this means, okay, here's how I'd like to frame it. So the next scheduled upgrade is in a little less than a year, and that is the schedule for which this proposal is being proposed, if you'll excuse me. So I wonder, could someone talk a little bit about the intersection of this upgrade along with others that are currently planned for next year's upgrade cycle?
Yeah, I mean, I could talk about that. So this is another upgrade. There's a 64-bit script integer upgrade, where right now the scripting engine works on maximum 32-bit integers when it's doing like its script operations. So that upgrade goes hand in hand with this one, and that we're basically adding features to the scripting engine to make it easier to do contracts. And so they kind of should go together, and they will for May 2022. So that 64-bit integer script upgrade is already implemented in Bitcoin Cash node, and it's been accepted by the ecosystem as far as I understand. And so those two things go hand in hand. Just the native introspection plus the 64-bit integers. It's just, you know, we're making it nice for people to write smart contracts, basically.
Sure, and maybe this isn't the case, but and please correct me if I'm wrong, but it seems like that's the sort of thing that's good to hear, that we're putting or things that are being added to the protocol all at once. Is that something that anyone would like to comment is a good thing, or is maybe not so good a thing, just for those of us who don't know?
Whoever wants to.
Well, I can note. So on the on many of the chips, we'll discuss in the specifications. We'll discuss their interactions with the others, with the other proposals that are happening concurrently. So in the introspection chip, there's a section describing kind of the interaction with the script integers change, 64-bit and reactivating opmol, they're actually they go particularly well together. It's actually a little bit messy not to do them together, just because there are things you can do with introspection where you will get back, for example, the Satoshi value of a transaction. You'll call this opcode, you get back the Satoshi value of a transaction, and that Satoshi value can be much, much larger than a 32-bit integer. So without putting them in both at the same time, there would be certain contracts that would stop working at is it 21 BCH, or depending on depending on your decimals, it could be smaller. So there are actually quite a few use cases that would cut into. Not the least of which is higher security vaults. If the maximum size of a vault is 21 BCH, you need a whole lot of them before you're going to get anything useful done. So there are some interactions like that are important. There are a few other proposals that have been proposed for May 2022, but none of them interact meaningfully with introspection other than the script number one. So those two are the ones that probably will be most looked at together, I would say.
On a more generic note, I'd say that the idea of it would be good or bad for things to come together is kind of odd to me. Things should come when they are ready, and we should be damn sure that they are ready like half a year before they actually activate, so that it's easy to predict and everyone knows what's coming and there's no question marks or confusions anywhere. Any potential consensus issues already worked out and all that. And I think as long as you get all that stuff done and people are really in agreement on things, it's okay to do many things at once. But if you're not really sure, then many things at once is a recipe for disaster.
And I'd also like to add on to that, just at the high level of what these chips mean for Bitcoin Cash. It's not just writing things down on paper and saying, oh, we ticked all the boxes, right? The key point here is that we're going through a process, and we're in the middle of kind of settling on a process that works for Bitcoin Cash, and it's very important to have that process. Because we don't have a king, right? We don't have someone who's going to stand up at the end and say, okay, yeah, that's all right, go ahead, right? We have to learn how to settle on our decisions ourselves as an ecosystem without an article that GP wrote previously. We said without the coercive decision makers, right? Without a coercive institution that says, well, 40% of you disagreed, and you guys can just leave. We need something better than that, because with a permissionless system like BCH, you can literally just walk away, and that's not a good thing at all, right? We don't want silly things or things that weren't actually all that valuable and just they were rushed and maybe they weren't fully thought through. And you know, you end up with a social split, which ends up leading to a network split and that kind of thing. So yeah, the chip process itself is very important that we're all collaborating on it and making it move ahead and following and making things happen. And like Jonathan said, make sure things are ready ahead of time. That's actually a big deal that a lot of blockchains don't do, and that BCH hasn't done well in the past, which is making sure that things are ready far ahead of time. You can't go in the last 3 months before something is released and then be changing the release. All of your exchanges, all of your pools, all of your businesses operating are going to seriously consider leaving if you start making changes at the last minute, because they have very expensive operations running, right? And they need to make sure that they can fit into their own plans how to upgrade the BCH network along with the rest of the network. And if you make that difficult for them, you're reducing the value of Bitcoin Cash. So I think the chip process itself and all of this stuff that we're working hard on is very important to the value of Bitcoin Cash.
Appreciate the perspective, and I think that's definitely worth pointing out to everyone following along, is that this process is in fact still evolving, and we're figuring it out as we go in the permissionless ether that is the cryptocurrency space. And that may be a good place to leave it off, but I will leave another 5 seconds or so of silence here just in case anyone wants to chip in. I mean, does anyone want to chat about anything about this chip specifically, or maybe even just reflect on the points that Emergent Reasons just made in regards to the chips in general?
Yeah,
please,
I'd
anyone,
like
go
to-
ahead.
Yeah, I'm thoroughly impressed by the professionalism with which this has all happened. I mean, the proposal itself is very well thought out, and it's been around for a while. People have had time to look at it and comment on it. It's been revised. We're doing this way ahead of time. Like, we have 9 months until the next scheduled upgrade, and we'll probably have this implemented, you know, ahead of 6 months before it's supposed to be deployed. I mean, we're figuring out as we're going along. It's just true, you know, but we've done great so far. Like, I'm really hopeful about BCH, and I'm just thoroughly impressed with you guys and with myself. I really am very happy about the way that this has transpired, and I think this is a great upgrade. It's something we need, and it's good. It's good to see. So we're figuring it out, but we figured out a lot already. So it's good to see that. Just thank you.
I wanted to throw one more point actually on top of that also. What I've often heard is people say, hey, well, you've got it ready, then let's just do it, right? Just put it out there. Why do we need to follow this 1 year schedule? Or, you know, the fact that it's a 1 year schedule isn't really the point. The fact is that there is a schedule is the point, because of those points that I mentioned about predictability. Right? If we're not predictable, if the network is not predictable, it's less valuable, period. And so that predictability is really important. And the schedule is a huge part of that, especially for businesses that can't, you know, change things immediately. They need to know ahead of time. They need to know what's coming. They need to be prepared. And they don't want to be changing things at the last minute. They want to put things in place and then let them run for a while, make sure things are smooth, make sure everything works. And so having a schedule is very important, and not just Jonathan said, you know, when things are ready, that's exactly right. You know, in addition to that, when they're ready, and then at the next scheduled time that you know everybody expects something to happen, then that's when things will happen, is at that time. So I just wanted to throw that out there. And I agree with Calin. Like, it's been pretty fun actually working on this and seeing everybody work together and just having things ready ahead of time, being professional about it, and being able to go out to exchanges and pools and other businesses and say, yeah, don't worry, we're going to be ready long ahead of time and we'll get it to you and it'll be smooth for you.
That's great. Thank you very much. So we'll, oh, and I should check. I apologize. I haven't checked for questions from the YouTube audience. So let me take just a second. I should have been keeping an eye on this. None. We got no questions. Everyone is quite content with native introspection.
Carry on.
So with that, thank you all very much for participating in this discussion. Thanks, of course, everyone for watching. You can keep up with the Bitcoin Cash Network discussions by subscribing to our YouTube channel and by following us on Twitter. If you have a topic that you think should be discussed, the place to start is bitcoincashresearch.org. And of course, thanks to them for running that platform. And finally, thanks very much to everyone behind the scenes who are making these network discussions possible. It's a lot of people doing good work to make sure that everyone's here on time, including me. So thanks very much to them. And we'll be seeing you.
Thank you, John. Thank you.
Thanks.
Thank you all.
Take care.
There you go.